Hi, my name's Stuart Lynch, and this is the 7th of 9 videos in the Building a Wordle App Clone series. In this video, we'll be introducing better feedback to our game players. We're going to be doing three things. We'll be creating what I call a ToastView. It's more of an Android concept, and it's a small message displayed on the screen, similar to a tooltip or a similar pop-up notification. A toast is displayed on top of the main content of an activity and only remains visible for a short period of time. And we'll be using this to display any warnings or congratulatory messages. The second thing that we're going to be doing is displaying a new game button once a game is completed, so our users can start a new game. And thirdly, we'll be creating a statistics view so that we can store our game results in UserDefaults so that we'll be able to review our progress over time. If you like this series, please leave a comment below and give the video a thumbs up. Be sure to subscribe to my channel and make sure you ring the bell to get notified of new videos. If you want to support my work, you can buy me a coffee. As we do at the start of every video, make sure that you start a new branch. We'll branch from Lesson 6 and call it Lesson 7. And again, make sure that it's checked out as the current branch. The ToastView is going to actually be very simple. So within our Views folder, create a new SwiftUI file and call it ToastView. We'll be passing in a string to this view that we will call ToastText. For the preview, just use a string not in word list. So I'm going to replace the body here with another text view, but use ToastText as the string. I'm going to set the foreground color to System Background and add some padding. And then for the background, I'm going to add a background that's a rounded rectangle with a corner radius of 10 and a fill that is a color primary. So this will be the reverse of the color scheme. In Wordle Data Model then, we're going to create a new published property called ToastText that's going to be an optional string. The idea is that whenever we need it, we'll set that string to a value, and then in our game view, we can add an overlay that will only be displayed if the toast text is not nil. This means then that we'll have to create a function that will use animation to fade in the assignment of that text to the toast text, and thus the view will be presented, and then a short time later, set it back to nil that will result in it fading back out again. So I'll create that function and I'll call it showToast with one argument. That's text, and that's a string. We'll use animation to assign it to ToastText. Now, 3 seconds later, we'll want to set it back to nil. So we'll do that then with an animation, a linear animation with a duration of 0.2 seconds, and then set the delay after 3 seconds, and set that text toast then to nil. Now, whenever our word does not exist in the dictionary, we can send a string to the showText function, and that happens to be the else clause of enter word. So, showText with not in word list. Let's test this out by returning to game view, and we'll add this overlay. We'll add the overlay to our VStack. And I'll set the alignment to top. And then only if let ToastText is equal to our data model's ToastText, meaning it's not nil, we'll display the ToastText view passing in that ToastText text. And I'll set an offset of Y to be 20 to drop it down from the top of the screen. Let's test. If we enter a word that's obviously not in the dictionary, the row shakes, and our toast view is presented for 3 seconds and then disappears. Now there are two other cases where we want to show a toast view. One, when we finish the game, we want something congratulatory to be displayed. And then if we fail to guess, we'd want to display the correct word. For the congratulatory message, we'll want to show a different word depending on how many guesses it took. Now I believe in the real game that there's a number of different words that it picks from for each different level, and that's something you might want to add. But for us, I'm just going to create an array of words that I can pick from. So let me create a new variable in Wordle data model called ToastWords, and I'll add 6 descriptive words that'll be decreasingly complementary, like this: genius, magnificent, impressive, splendid, great, and if you get it on the 6th guess, few. Now, whenever we win the game, we'll want to pass in to the toast the string corresponding to the index in the array that matches the try-index that we are at. Let's test this out now. The word is wilts. So let me start by entering walks. It's incorrect, so now let me do the correct word, wilts. I'm successful, and toast displays the word magnificent. Now once the game is over, we can display a new game button. And I'm going to do this on the navigation bar right beside the question mark button. However, I only want that new game button to be displayed if the game is over, and not if we're in play. So I'm going to embed that leading bar button item in an H stack. And I'll add a second button as the first item in the H stack and use text new. But we'll only want to do this, as I said, if we are not in play. And I'll set the foreground color to primary. For the action then, what are we going to do? Well, we're just going to call the new game function from our data model. Let's test. The word is mucky, but let's test an incorrect word first. Great, I see it's still working. I haven't broken anything. Now let's test the correct word. Indeed, we get congratulated, and after 3 seconds, the new button appears, and when we tap on it, we're into a new game. Well, now that we have a functional game working, we can add some bells and whistles, and the first thing that we're going to do is add statistics to the mix that will save our game and update existing stats to a JSON string in the UserDefaults that we can decode and use to present the statistics in a view. So the first thing I'm going to do is create a struct for our statistics. So within the models folder, create a new file called statistic. And within there, create a new struct of the same name, but it has to conform to the codable protocol. I'm going to need 4 stored properties. I'll need an array of ints that I'll be using to represent the frequency of times that we were successful on a certain try. The total of those then will be our number of successful or wins, and we'll be using those to display the bar graphs. So we'll create an array of integer repeating a 0 6 times, because that's what we're starting off with. We'll need to know the number of games we've played so that we can create a percentage. So that's an int, initially at 0. We'll want to know what our current streak is. How many days in a row have we successfully, or how many games in a row have we successfully won the game? So another int starting at 0. And then we'll need to know the maximum consecutive number of times we've won. Another integer called max streak starting at 0. So I can create a computed property to compute the number of wins as an int by summing up the frequencies using reduce starting at 0. We'll need a function that will save our current stat to UserDefaults. And since statistic conforms to codable, we can use a JSON encoder to do that. So I'll call the function saveStat, and then I'll use an iflet to see if I can try to use the JSON encoder to encode this object, self. And then I can use UserDefaults standard to set that encoded string for the key stat. For the load function, we'll need to create a static function that returns a statistic. First, we'll use iflet to retrieve from UserDefaults the object for the key stat as data. And we're assigning that to saveStats if we're successful. If we're not, we'll just return a new statistic object, meaning we've never had one before. If so, then we can use another iflet to try and use the JSON decoder to decode the statistic object, self, from that saveStat, and then return it if we were successful. If we weren't, didn't exist, then again we'll return a new statistic object. To update the stat, we'll need another function that will update the stat, but we'll need to know whether or not we had won the game or not, and we'll need to know on what attempt. We'll always need the Boolean property, but if we don't win, we don't need to know the index of the row we are on, so we'll make that optional and set it nil by default. Whether we win or not, we'll need to update the number of games immediately. But you see, as soon as we try to do that, we get an error telling us that the games is not mutable because self, or the struct, is immutable. And this is true. You can't by default mutate properties of a struct. However, we can mark this function as being a mutating function, and then it will allow us to do that. Then we'll increase the streak only if there is a win. And then if there was a win, we'll increase the frequency at that index by 1 and set the max streak to be the maximum of the one that we're on or the current streak. And then we can call the saveStat function. Returning now to the data model, we must make sure to call this function when the game is over, and this is done in the enterWord function. First, if the words are matched, we can specify that the win is true and pass in the try index where we won the game. If we lose, we can just specify that the win is false because we're not going to record a win. We should also remove this print statement and call the ToastView here so that the correct word will be displayed if we don't successfully guess it. Well, now we can create our statistics view to match the one that Wordle provides us. So in the Views folder, create a new SwiftUI file and call it StatsView. We'll want access to our data model, so we'll need an environment object for that. And then we'll fix the preview from complaining by injecting a Wordle data model into the preview provider. Before we finish designing this view though, I want to go back to our data model and create a new property that's called showStats and initialize it initially as false. Because we already have a button on the toolbar that when we toggle, we want to show that statistics view. So it needs a published property in order to know when to be presented. So we'll also need another property that we can use to load our statistics in. So I'm going to call that current stat, and it will be a statistic. And then when we initialize this class before we start a new game, we'll just load in the statistic into this property using that static property from the statistics struct, loadStat. So when our game view is showing, I'll want to toggle this to show the statistics view when the game is over. So within the showToast function, within the animation where we set toast text back to nil, we'll check if the game is over and then use that same animation with another delay of 3 seconds to toggle that showStats property. In game view then, we can embed the entire navigation view in a Z stack. And then as the second item, conditionally present a stats view based on the showStat boolean. And then for our toolbar button, we can toggle that showState property within an animation block. Okay, let's do our stats view design then. We'll start with a VStack with a spacing of 10. I'll apply a horizontal padding of 40. I'm going to set the frame to a width of 320 and a height of 370. And then for the background, I'm going to use a rounded rectangle with a corner radius of 15 and a fill that is a color view with a system background. And I'm going to add some more padding all around. Let me now add a shadow with a color of black and an opacity of 0.3 with a radius of 10 all around. And finally, I'll move it up a bit and set an offset of -70. Next, within the VStack, I'm going to create an HStack. And I'll start with a spacer and add a button with a label of the capital X. And that's going to be my dismiss button. So for the action, all we have to do is, with animation, toggle the data model's showStats property. After the VStack, I'm going to add a spacer, push it up. I forgot one thing. For this button, I like to give it an offset of X being 20 and Y being 10 to place it in the top right corner. Now, before the spacer, I'm going to add a text view with a string statistics, all in caps. I'll give it a headline font and a font weight of bold. For the next item, I'm going to create an HStack. And inside we'll create 4 VStacks. And the VStack will contain our statistics, and all 4 will be similar. So for the first then, we'll create a text view using the data model's currentStat.games property as a string. And I'll set the font to large title. Next, a text view using the string played. I'll set the font to caption, and I'm also going to set a frame where the width is set at 50. And then finally, I'll set the multi-text alignment to center. As I said, all 4 views are going to be the same, so let's extract this as a view. And I'm going to rename that extraction and call it single stat. Now we're going to have to pass into that view a value and a string. So I'll create 2 properties for those. And then I'm going to replace the hard-coded values with these variables. So back up in the HStack then, we can pass in the values to single stat. For the next block, if the user's displaying this before any games have played, we don't want to display the percentage of wins. So if the current stat.games is not equal to 0, we can calculate the percentage by dividing the number of wins by the number of games, and we'll multiply that by 100 and convert it to an integer. And for the text view, we'll use win percentage. The third row will be the streak, using the text current streak. We'll also ensure that the view gets priority, so I'm going to set a fixed size where the horizontal is false, but the vertical true. The last one is almost identical, except that it's for max streak. Let's align that HStack to the top. Next is another text view using the string guess distribution. And again, we'll use a headline font and a font weight that's bold. What we need to do now is to create the views that will present the bars indicating the number of wins on a particular guess. So we'll create a VStack with a spacing of 5. And within there, we can loop through all of the attempts from 0 up through 5 to get that index. To create the bars, I'm going to use an HStack with first a text view displaying the index plus 1. So the first being 0, we needed to show a 1. If there have been no wins on this attempt, we're just going to create a rectangle and fill it with the color wrong. And I'm going to set the frame to a width of 22 and a height of 20. Then I'm going to use an overlay on top of this of a text view using the string 0 and setting the foreground color to be white. So just a small little bar with a text showing 0 on top. Now, if the frequency is greater than 0, we'll do a similar rectangle, but we'll need to expand it to be the maximum width of our VStack for the maximum frequency, and then scale all the others accordingly. So we'll create an else statement, and while we're at it, we'll add a spacer below. Within the else statement then, first let me unwrap the frequency's max value and assign it to a variable called max value. Then I can create a similar rectangle. Now the fill color will depend on whether or not our try index matches the index that we're iterating over and that the game is in fact over. If those two conditions are true, we'll set the color to be that green color, the correct color, else it will just be the wrong color, the gray color. So for the frame, the width will divide the current frequency by the max value and multiply it by 210. That's basically extending to the end of this rectangle or this overlay. For the height, we'll keep it at 20. And then finally, we can set an overlay using the current frequency and set the foreground color to white. I'm going to add some horizontal padding of 5 and then set the overlay alignment to trailing so that the number will be at the right of the extended bar. Let's test. If I guess correctly the first time, I see that the first bar is green and I'm at 100%, and my current streak is the max streak, and that bar on the first attempt is extending the full width of our statistics view. Let's try a win on the second guess this time. When the stats view is presented, we see that the stats and the bars adjust accordingly. How about another win on the first try? Notice that the first bar is still extended all the way to the right, but the second one has been scaled down accordingly. Finally, let me go through and fail to guess the word in all 6 attempts. My percentage is now less than 100. My current streak is now at 0. And the max is at 3. Those are the number of successful wins I had. And none of the bars are green because I didn't win. Well, that was a long lesson, and that's it for now. In the next lesson, we'll be looking at how we can give our users the ability to change from light to dark mode and create a share sheet so that they can share their results. In the meantime, make sure you commit your code to your repository.